Hey everyone, what's up? So in the last video, as you remember, we have instantiated our chess room class inside this chessboard part, and we have obtained a reference of a board object inside this chess room and displayed the initial status or initial state of the board. So as I said earlier, today we are going to start building our chess players. But before we do that, we need one small thing left to do. So that is to create a class for a chess move. So when we work with chess players, they need a definition of a chess move. So we are going to define that now. So inside our chess core plugin, and under it, this core model package, we are going to create a new class called chess move. So this class actually holds the necessary information about a move. So it will be a very simple class. So when we make a chess move, there are some things involved. For example, a piece is involved. It moves, so from one square to another. So there are two squares, obviously, and they may or may not be a piece to be captured in the end of the chess move. So let's go ahead and define our squares first. Private square. Okay, let's call this initial square. And also we have this target square, and let's define a piece target piece. So that's all. You may be wondering why are we defining the target piece and we are not defining the moving piece. So the reason is this. In the section we are going to implement the alpha-beta-pruning algorithm. We will need to undo some moves. So we'll make or try some moves and we will undo them. So if you don't hold a reference of the captured piece, this target piece, we won't know if we have captured a piece or we didn't as a consequence of this chess move. So we can always get back the reference of the moving piece because it's not disappeared. It's moved from this initial square to the target square. So I can look at the target square and get the moving piece reference. But I cannot get a target piece reference if I don't keep track of it. So that's why we are not including the moving piece here, but we are including the target piece. So this being said, let's quickly define a constructor and getters and setters for this simple class so that we can use this in our player classes. Okay, and also delete this and getters and setters. All right, that was pretty easy, and now we can start creating our chess players. So firstly, we need another plugin project called player. So let's call it example chess player. So everything related to chess players will be inside this plugin. So let's create a package chess player. Okay, and let's create our base chess player class. So chess player. Okay, so this will be our base class. What this means is we are going to create other classes, other player classes, but they will extend this class. So this means that this class will hold the common attributes or common methods of every chess player. So types of chess players are, for example, the main difference is a player can be an artificial intelligence player or a user. And there may be different types of artificial intelligence players. For example, you can implement alpha-beta-pruning, you can implement minimax as the artificial intelligence algorithm, or you can do something like a random move maker. So they will each have a different class. So before all those, let's create this class first. So what are the common attributes and methods of a chess player? So a chess player must know of a chessboard. So let's first create it, private board. And also each player should know its side. So if it's black or white. Okay, let's create a constructor. Chess player. Okay, so of course we need to import this package from the core plugin, this model package, because now we are in a different plugin and we need to import the required dependencies in this manifest.mf file. When I hover over this and click add to imported packages, it will do that automatically. And let's import in our Java class also. Okay, so now let's think about the methods. So what methods should this chess player base class have? So every player should be able to make a chess move. So that's why we have created this chess move class. So let's go ahead and define a method called make move. So public void make move, and it will take in a chess move argument. We'll implement this method later. Let's import that. And also there's one more method that should be implemented for a chess player, and that's to decide a move. So let me type that first and explain later. Public chess move decide move. Okay, so as you see here, this method will return a chess move object. So for example, take a random move generator player. It simply scans all the legal moves that he can make and chooses one randomly. This operation will be performed in this method. And for example, in the alpha-beta-pruning player, this method in the corresponding class, so it will extend and override this method, obviously. So in the decide move method of the alpha-beta player, the alpha-beta-pruning algorithm will be implemented. And finally, for the user, this will be null, so return null, because the user decides which move he will choose inside his head, so it will not depend on an algorithm whatsoever. So since the base class will be the user class, because it doesn't need to override anything, in this class it's null. But when we implement a random move generator or the alpha-beta-pruning algorithm, we'll override this method and implement the correct algorithm in that class. So I'm going to skip this and leave it as null for now. So the make move method, on the other hand, will be common for each type of player, because there will be no difference between the types of players in regards of how to make a move. You simply take a piece and move it to another square and capture another piece if there is one. So we can implement this inside our base class, and we don't have to override it on the other player types. So how do we make a move? So this chess move object has some attributes that we can use. For example, let's start by checking if we are capturing a piece or not. So if you are capturing a piece, we should be able to keep track of it inside its army. So let me define an if statement. So if move get target piece is not null, so there is a piece where I'm going to move my piece. So I'm capturing something. So I'm going to do something here, but let me skip that part for now and implement the basic part. So what's going on when we are making a move? So initially, let's get a reference of the moving piece. So piece moving piece is move get initial square, get piece. So that's my moving piece. And also we should import this piece package as well from this core plugin. So now that I got the moving piece reference, I can update the squares and the square that this piece is seeing. So let's do that first. Moving piece set, there's no set square method in the piece class. Okay, let's create it. Let me type that now here. Set square move get target square. So this is very simple, I guess. I'm updating the piece, the square reference of this piece object. So let's create a set square method inside the piece class. Okay, so square equals square. So this and square. All right. So let's go back to our chess player class. So we have updated the square reference of the piece. Now let's update the square objects. We should change the piece references for the squares. So let's update the target square first. Move get target square set piece. So moving piece. So what I did right here is the target square now has the moving piece. It was either blank or it contained the captured piece earlier, but now it has the moving piece. And also the initial square, get initial square, set piece is null. So there are no pieces in the initial square anymore. Alright, so let us now fill this if statement. So what I'm going to do if I'm capturing another piece is I'm going to update the living or alive and dead piece lists inside the corresponding army. So let's get a reference of the army. Army is board get army, and this will be the opposite side. So this chess player, let's say this player is white and his opponent is black. I'm going to get the black army here. So I'm going to define a method called opposite for this side class. So it's an enumeration type, if you remember. So I'm going to add a simple method to get the opposite side, the public side. No, opposite. So if return, if this is white, return black, and if this is black, return white. That's what I'm going to do basically. So this equals white, return black, or else return white. Okay, so let's go back. Now I can get the opposite side. So I'm going to need the opponent's army. So once I have the opponent's army, I can update the living or alive pieces list and the dead pieces list. So what I'm going to do is this. If you remember, we have created a method called bury piece. So what this does is removes a piece from the alive pieces list and adds it to the dead pieces list. So the only thing that I'm going to do is call this method. So I'm going to bury a piece to the graveyard, so to speak. Okay, so army bury piece move get target piece. Okay, what does it complain about? So it says this is a square. So let me close this and reopen because it may be a bug. But it still complains. So this target piece returns a square. All right. Oh, okay. I see now. I defined the target piece as a square object. So this will be piece. And I have to update every reference now. Okay, and this will also be piece, and this will also be piece. Okay. Now we should be fine. Yes, okay. So this is the make move method. Alright, let's end this video right here and we'll continue building our players in the next videos. So see you later. Take care.